The fact that you clicked on this video tells me that you're probably one error message away from abandoning your GoPro altogether. If you're like me, you've probably clicked on this GoPro troubleshooting link countless times just to see how much battery life you should actually be able to expect out of your camera. Today, we're going to be testing my Hero 11 Black to see how much it truly can take in this 100 plus degree temp and how much power each individual setting actually draws from the camera. So stay tuned and let's dive into it. So what exactly are we going to do in this video? First of all, we're going to quantify the incremental power draw of each individual option on the camera, i.e. Hypersmooth, screen brightness, GPS, things of that nature. And then lastly, we're going to determine what the maximum power draw is for this camera in extreme climate conditions, such as 100 plus degree temps, zero wind flow, and the camera will have been out in the sun prior to testing. So now for the rig rundown, we're going to be using my Hero 11 Black plugged directly into this Wattmeter, and we'll be using that to conduct all of the incremental power draw testing. So for each of the features like Hypersmooth, we're also going to use this infrared temperature gun that will show us a baseline temp once the camera is set out in direct sunlight for a little while, and then what the maximum temp is before the camera shut off. Lastly, we're going to use an external power bank for all of those outdoor tests to see what the max stable power draw is for this camera. Let's get into the data, specifically our baseline information. So as you can see here, I've got our maximum and minimum power draws listed. So with everything maxed out and turned on, the camera pulled 11.1 watts. On the contrary, with everything turned off, so base functions and running a resolution at 1080p at 24 frames per second, I was able to get the camera down to 3.8 watts. So that is pretty much just a hair over idle, which is pretty impressive with it recording. Our next data point is the live preview function. So this is controlling the camera from your phone, and everything from this point forward is pretty much conducted in 4K at 60 FPS for continuity. So with this function turned off, the camera pulled 6.4 watts. With it turned on, it pulled 7 watts. And this is essentially being able to see what the camera sees live on your phone and pause recording from the phone. So our net cost here is 0.6 watts. So this is a pretty heavy offender. Next, we have Wi-Fi status. As you can see, whether it's on or off, it really doesn't change the power consumption that much with a net of 0.1 watts. So not a whole lot to talk about here. For our third option, we have wind settings, which are either off, on, or automatic. And as you can see, there's no net change here, so feel free to use whichever setting is necessary for your project. So on to colors. As you can see, there's a zero point 0.2 watt net here. 10-bit colors, in my opinion, is a pretty big one to have on. So if you can afford to have it on, I would suggest keeping it on. Bitrate is another one that I would suggest keeping on if you can, especially if you record fast-moving objects. So as you can see here, standard bitrate 6.4 watts, high is 6.6 watts for a net of 0.2 watts of additional power draw. Much to my surprise, having the front screen on really didn't add that much to the power draw. As you can see here, there's only 0.1 watts of additional draw with having that screen on. This one's a bit of a head scratcher. So I had the rear screen timeout set to 1 minute. And much to my surprise, once the screen went off, the power draw actually increased by 0.2 watts. Now, I don't see how that's possible, but that is what the Wattmeter showed. So I wouldn't personally take too much stake in these results, but try it and see. Maybe it does the same on your camera. Now, brightness is a fairly significant one. So as you can see here at 10% brightness, which is the lowest you can set the camera at, we're at 6.4 watts. When we scale it up to 100%, we jump up to 6.8 watts for a net of 0.4 watts of increased power consumption. So yeah, pay good attention to this one. I'd keep it as low as you possibly can. Voice control is another one of those functions that really didn't do a whole lot in way of power consumption. So at 0.1 watts of net, I don't know that it's really necessary to turn it off. Maybe it uses more if you're actually using it, but with the setting toggled on, hardly any change. GPS is another one that's a little bit of a head scratcher for me, as I've always heard to turn this off to save battery, but as you can see here, it was really only a net draw of 0.1 watts, so not a whole lot of savings here either. Now, Hypersmooth is somewhere that you really can save some power draw. As you can see here, with it toggled off, 6.4 watts of usage. With any of the other three settings, so that's on, boost, and automatic mode, all three draw an additional zero point 0.6 watts at a total of 7 watts. So my suggestion, if you're trying to squeeze every little bit out of this camera that you can, maybe do some post-recording stabilization with a program like GyroFlow. And now we've reached the resource heavy options. So let's talk about aspect ratio. So the most common aspect ratio is 16:9. That's what I use for our baseline here. 6.4 watts of consumption. If we move up to 4:3, we've got 7.5 watts of consumption for a net of an additional 1.1 watts. And then by moving from 4:3 to 8:7, we bump up to 8 watts for a net of an additional half watt for a total delta of 1.6 watts from 16:9 to 8:7 if you're wanting to utilize that full sensor. In testing frames per second, I used a resolution of 1080p for everything, just because it allowed me to sample everything from 24 all the way up to 240. But as you can see here on the chart, 24 came in at the lowest draw at 3.8 watts. We bump up just a hair by 0.2 watts to 4 total, going up to 30, which is a great frame rate for just about every form of content. Doubling the frames per second to 60, we jump up 1.3 watts. I know my net here says 0.7. My bad. That is incorrect. Doubling the frame rate again, we go from 5.3 watts to 5.8 watts at 120 frames per second for a 0.5 watt gain. And lastly, doubling the frame rate from 120 to 240, we jump up 1.2 watts. So very substantial draw difference here, and that takes us to a total of 7 watts. So from top to bottom delta, you can see 3.2 watts. This is arguably the largest place to save in terms of power draw. And let's see if it changes things as much as resolution does. Much to my surprise, it does change things more than resolution. So as you can see here, we had a total net change on frames per second of 3.2 watts, whereas resolution is only 2.6 watts. So for resolution, I use 60 FPS on all the frames. As you can see here, 1080p, 5.3 watts is our baseline. As we jump up to 2.7K, minimal increase, we jump up 0.6 watts, but that is still significant. Going from 2.7 to 4K, we jump up an additional 0.5 watts. And then lastly, going from 4K to 5.3, this one really surprised me. We jump up 1.5 watts. I thought those two resolutions were fairly close. Apparently not. So that's a great place to save on power draw if you still want the most bang for your buck in terms of picture quality. And this brings us to our last data point, the max sustainable wattage from this camera. In my testing, the camera was outside 96-degree Fahrenheit temps. It was stationary on a tripod in direct sunlight. I preheated the camera to 125 degrees Fahrenheit, so I let it sit for about 15 minutes until it didn't increase anymore. There was zero wind, no breeze whatsoever, and I was using that external power pack that I showed at the beginning of the video. Anyway, all I could get away with here was 1080p at 30 frames per second and high bit rate. So a max consumption rate of 4.2 watts. This allowed me to shoot for 30 plus minutes without the camera overheating, short circuiting, etc. So as I climbed down the ladder, I started with 5.3K at 60 and just kind of worked my way down. So every time I'd stress test the camera, it would shut off between 148 and 150 degrees Fahrenheit. It wasn't until I ran these settings that after about 25 minutes, I went outside, I ran the temperature, and we were at about 145 degrees Fahrenheit. I went back out 5 minutes later, noticed that the temp had dropped to 143, and that's when I decided, okay, we have achieved a truly sustainable level for the camera. So, for any of you like myself who shoot content in states or areas of the world where it is quite hot, this is about all you can get away with on a Hero 11 and not have to worry about it shutting off. I specifically shoot a lot of motorcycle content, mostly track content, and in that, the camera sometimes sits behind the windscreen. So there's zero airflow. It's like a magnifying glass on it. It's anywhere from 95 to 100 degrees Fahrenheit outside. I mean, just the worst conditions you could dream up for a camera like this. So this stress test was about as close as I could get to that on the camera. And I did decide to use an external power bank instead of using the batteries just because that's what I'm going to start doing on my bike. These batteries get piping hot and it does cause the camera to overheat prematurely. So, closing thoughts on the test. I am excited that I was able to find a configuration that allowed me to record indefinitely, but I am kind of bummed that it's at such a low quality level and lower frame rate than I'd like to shoot at. I think it's kind of a bummer that, the camera is advertised being able to shoot at these higher resolutions and frame rates. But, if you ask the camera to do that for more than a couple of minutes in, heat levels such as what I record in, it just can't do it. So that is a bit of a bummer, but had a lot of fun recording the data and conducting these tests. So hopefully you guys got something out of the video, and hopefully now you've got a good baseline setting that you can reliably count on for next time you shoot in some harsh conditions and you need your camera to last for a while. So if you enjoyed the video, feel free to like and subscribe, and I will hopefully have some more content up for you guys soon. Thanks.